Step Bros, your master is back in fucking town, baby. So this is gonna be, basic neuroscience. This is gonna be a super quick one. We're gonna fucking jam that shit in there and fucking do this shit quick. So, I got shit to do. So, get straight to the fucking video, play that intro, and let's fucking pound that shit to kingdom come, baby. Let's go.
Beautiful self-love technology.
Fourth take. Nah. Okay, let's get to the juicy shit. Long story short, very quick video. The cerebral cortex, deeper structures, the white matter around the brain, and neurotransmitters. A little quick one into that. So, long story short, what is the cerebral cortex? It is the outer layer of the cerebrum, which is just the basic main, one of the three big daddies of the brain. What the cerebral cortex does is it's like the brain's, biocomputer processing factory, which processes literally everything you see, feel, not smell, touch, hear, and it kind of gives this to the frontal lobe to kind of decide what to do with this information, etc. Now, there's 4 lobes, 16 main cortical areas which do all the dirty work, and that's pretty much it. Oh, and the reason there is 4 areas and not just one big, huge processing plant, one big ballsack of processing factory shit, is because it allows the brain to be more efficient, more specialized, quicker in processing, because these different areas do different kind of processing, which then allows the brain to kind of take these huge dumps of information and distribute them around the brain, allowing them to have this huge mental model built in like fucking a second. It shit's crazy. And yeah, that's pretty much what the cerebral cortex does. Now, to understand how it does this is it's neurons. Now, the thing with neurons is that they make up pretty much every brain structure. Every single brain structure, as far as I'm concerned, is made up of something called grey matter. Now, grey matter is just a very advanced and special word for being made up of neurons. That's it. Blood vessels, some other cells, some boring shit. It's just made up of 90% neurons. That's all you need to know. Now, what is a neuron? A neuron is a very specialized basic cell within the human brain, which has 3 main functions: sending, receiving, and combining information. That's all it fucking does. Now, how does it do this? Well, it has 5 or maybe 6 components, one being the dendrite, which essentially collects neurotransmitters, which then give these signals to the soma, or the main body of the neuron, which then integrates these signals. And then, this is going to sound a bit complicated, if they surpass a certain threshold of the axon hillcock, being pretty much the decider if the neuron fires or not. I haven't explained that. Fuck, what's going on anyways. Essentially, the neurons fire an electrical impulse, which then releases a neurotransmitter, which a neurotransmitter releases information, which then binds to other neurons' dendrites, repeating the entire process and essentially creating a pattern. Now, the special thing is, why, how are these patterns formed if these neurons are, sending these neurons to these neurotransmitters to all these other neurons? That's GABA. Fuck, okay, I'm going too far into the future. Now that we've explained the basic kind of principles behind neuron biology, let's get into, check my board, deeper structures. Yeah, deeper structures. Deeper structures consist of the thalamus, hypothalamus, hippocampus, the amygdala, and the basal ganglia. The hippocampus and the thalamus are pretty much the only important ones, because the thalamus is like the relay station of the brain. It takes in basic information given by the organs like the eyes and the ears and etc., and it kind of translates them into a very basic neural pattern, if that makes sense. I don't really know what that means just yet. Obviously I know what a neural pattern means, but how the eyes and the ears do this is a bit confusing. But when they when they complete this function, they then send this basic, extremely broad information to the thalamus. Now, the thalamus kind of buffers this neural pattern and then sends it to the specific and appropriate neural cortical area, like the if you see something like an apple, all the visual features will start to be processed by the occipital lobe's primary visual cortex, which processes things like the edges, the you know, the depth, the shape, etc. And yeah, so that's deeper structures. Hippocampus, that's important too, because it forms this kind of codex, not codex, it's the brain's ledger. What that means is whenever you learn or you do something during the day that's quite important, I don't even think you have to make it important. It's just anything that really happens that day. If you know you have like a talk with someone, etc. Those neural patterns are essentially summarized into one kind of input. Long story short, they're summarized. All these neural patterns, they're sent to the hippocampus, which then creates an output of one summarized code. Okay, now this sounds confusing, but long story short, what the hippocampus does with this code is it kind of replays it during your sleep. So whenever you sleep, essentially your hippocampus is kind of activating this very summarized specific code again and again, reacting these neural patterns which originally happened in your brain during the day, when you were speaking to someone, when you were eating, anything like that. Essentially strengthening the neural patterns within your head and allowing you to learn while you sleep. It's very important, it's very beneficial, and I kind of specialize into that a bit more later on because it's clearly quite an important one for memory, maybe even advanced neuroscience. I'll kind of able to explain more on that, excuse me. But yeah, so that's thalamus, hippocampus. The amygdala speaks for itself. It just adds emotional significance to memories. That's very basic, you can understand that easily. The hypothalamus, it detects kind of imbalances within the body, like if you don't have enough hunger or no food in your body, it triggers neural patterns within your brain, which then allows you to experience hunger or thirst or tiredness. So long story short, it just makes you hungry and go to sleep, pretty much. And then the last one, the basal ganglia, it just picks actions. I assume this is why Tourette's is a condition, because their basal ganglia cannot pick or efficiently pick the correct action selection for doing things. That's why you kind of get these jits, the random speech production, all this kind of stuff, because your basal ganglia cannot pick or efficiently select the one proper action you should take at this time. Now that's one that I don't know, you might want to look into that, or that's kind of my job. I'm fucking this up, sorry guys, I'm a bad teacher. And yeah, so next up, white matter. White matter, very weird and special word. It isn't special at all. There's grey matter, which is actually important, then there's white matter, which simply means a part of the neuron, so pretty much grey matter, called the axon, which is like the big daddy, which sends information. The white matter just describes these axons of the neuron being wrapped in this thing called myelin sheath, which is just fat, pretty much, making it insulated and warmer. I think, I mean, I don't know what else insulation would possibly fucking mean. Essentially allowing for a faster transmission speed of these electrical impulses, these electrical impulses to then reach a neurotransmitter or an axon terminal. Got that one wrong, I think, yeah. And yeah, then now the big daddy's neurotransmitters. So there's 4 basic ones, there's obviously way fucking more. That goes for everything in this video. These are just the basic, easy ones to understand. There's obviously way more, but that's like advanced territory. Like we ain't developed enough for that. This is just quick, basic shit. Neurotransmitters, they, long story short, allow you to kind of send signals and shit within your brain. That's quite complicated, so I won't get into that too much. There's 4 main ones: glutamate, GABA, dopamine, and acetylcholine. I think I'm butchering that, but those are the main 4. That's the gist of it. Now glutamate, just to really clarify this, neurons with mainly, the main kind of neurons within the cerebral cortex only release glutamate. Now to make that clear, glutamate is a communication neurotransmitter which allows it to create communication, or essentially allowing for neural patterns to exist, right? Now, with the entire cerebral cortex kind of consisting entirely of these neurons which only release glutamate, it's going to allow the entire cerebral cortex and deeper structures to communicate and create neural patterns. That's kind of what the brain does, right? But scattered within this huge pie of glutamate are GABA neurons, which only release GABA. Now, what GABA does is it sharpens this communication or neural patterns that the brain produces, essentially allowing you to summon more detailed information based on whatever you're trying to process. GABA is like an inhibitor neurotransmitter, meaning it kind of quietens or ensures no other extra or unnecessary neurons that accidentally fire, or it just makes sure they don't fire, if that makes sense. Hopefully I'm not butchering that. Dopamine speaks for itself. Actually, no, it doesn't. Dopamine strengthens neural patterns. So whenever you smoke, drink, etc., there's a reason why you find that so like thrilling, addictive, and you want to go back to it. It's because you're more susceptible, or you find it easier to activate that neural pattern within your brain, thinking about it, saying, oh, I want to do this, I want to do, I want to drink again, I want to smoke again. It's because dopamine, when you release it, it strengthens the fuck out of any neural pattern which is associated with whatever is like releasing this dopamine, like smoking, drinking, sex, anything, right? That's how addictions are made. That's why human beings are so susceptible to addiction, because the basal ganglia, or parts of it, release this neurotransmitter, which then strengthens the fuck out of any potentially addictive neural patterns. And yeah, that's pretty much the gist of it. And then there's acetylcholine, I'm butchering that again, essentially like the focus lens of the brain. Have you ever wondered why when you're studying, there's a reason why you don't feel the clothes against your skin, any extra like buzzing noise or anything like that? Your focus, this is pretty much where focus comes from. It's from this neurotransmitter, which allows you to kind of cancel out any irrelevant sensory information and focus on what actually matters, if that makes sense. Now that's a very quick, basic, this is basic neuroscience, basic guide to the cerebral cortex, deeper structures, white matter, and neurotransmitters, and neuron biology. Let's go. So hopefully you guys enjoyed-ish, or found this informative or helpful. This isn't really for your benefit. My 38 subscribers, I know you guys can give a fuck about this shit. It's more so for me and potentially this channel. Let's wrap this thing up. Thank you for watching. The king, get to work as per, and yeah. Thank you guys, and see you in watch the next one. Thanks.